Hi, I'm Darshana, a product manager on the AlloyDB team. AlloyDB is an AI native database that isn't just a static store for data. It intelligently understands and processes your data. In this video, I'm going to teach you about AlloyDB AI functions. What are they? They help bring the power of foundation models like Gemini to your data. Let me give you a concrete example. Let's assume you have a retail website and your customer searches for shirts for a summer vacation in Santorini. Your database might not know where Santorini is and what the weather is like there in summer. But Gemini has this knowledge. What you can do with AlloyDB is use hybrid search to return the top 1000 results. And then you can use one of our out of box LLM based AI functions, the ai.rank function, to re rank these results based on knowledge that Gemini has on the types of materials and shirts that are best suited for summer in Santorini. You can prompt this function directly using natural language, as you can see in the example here. And voila, your customers get the most relevant results that are grounded not just in your data, but on knowledge that Gemini has. We have three generally available LLM based AI functions today: rank, which we spoke about; if, which helps with intelligent filtering, such as determining if a transaction is fraudulent or not; and generate, which helps with generation use cases like converting unstructured data into the JSON format. We also have a semantic ranker version of the rank function. We also have the times FM based forecast function, now generally available. This function helps predict the future using your historic data, and it unlocks a plethora of use cases, from optimizing retail inventory to projecting future revenue. We're also very excited to bring to you brand new AI functions. Analyze sentiment and summarize help with classifying emotional sentiment and condensing lengthy text into succinct summaries. And there's also aggregate summarize that generates summaries across multiple rows of data. Customers tell us that AI functions sound amazing, but they often have a question. What are the performance and cost implications of invoking an LLM or foundation model for every row of data within my table? Fear not, because we have some amazing techniques to boost performance and lower costs. First, we're very excited to bring to you optimized AI functions, starting with support for ai.if. This uses a revolutionary piece of tech. We train a local model on your embeddings and LLM outputs and invoke this model instead of the LLM. In benchmarks that we have done, we've seen the ability to process up to 100,000 rows per second at less than one tenth of a cent. And this is up to 23,000 times faster and up to 6,000 times cheaper than doing row at a time LLM calls. We also have asynchronous bulk prompt methods, AI function acceleration, and array based processing that can boost performance. So, with that, let's visualize what we learned about AI functions through a demo. Here is Symbol Gadgets, a marketplace for tech enthusiasts. Let's assume I'm a buyer looking for a gaming console. I find this Alpha Core console. It has many reviews and I don't have the time to go through all of them. Using the aggregate summarize function, this AI Insights section distills those reviews into a short summary. I also see the vibe of the community through statistics on review sentiment. And this is powered by the Analyze Sentiment function. This gives me the information I need to make a purchasing decision. Next, Say I look for a camera that satisfies this condition: waterproof at depth 40 meters or deeper. Traditional hybrid search might show a 10-meter depth camera just because the description says waterproof. But that's a false positive. For example, see these hybrid search results. The descriptions mention nothing about depth. These products may not really work at a depth of 40 meters or deeper. Now let's see what happens if we use the ai.if function for the same prompt. Here, ai.if doesn't just look for closest matches. It also assesses the specific criteria against the embedding data. If we look at these product descriptions, there is a mention of depth. All of these products meet the criteria of working at a depth of 40 meters or deeper. If I modify this prompt and change 40 meters to 80 meters, I get 0 results. I am given the truth that this database contains no products that meet my criteria of working at a depth of 80 meters or deeper. If I try the same prompt using hybrid search, I do see results. And that is because the nuance of depth isn't fully understood and I get closest matches. Let's look at the code snippet for the 80-meter prompt example using AI functions. Here you can see we are using optimized ai.if. We've created a local model right inside AlloyDB using a prepared statement. When we invoke the ai.if function, the local model is called instead of the LLM. We get massive performance boosts and significant cost savings in this optimized mode. Now, switching gears, let's assume I'm the admin of Symbol Gadgets. Here are some tools that can help me. First, our AI product tagline tool uses the ai.summarize function to read a product's description and return a punchy tagline for the product. Second, the AI data extraction tool can extract from product descriptions a standard JSON output using the ai.generate function. This can help me with automated catalog management. And finally, here's a forecast tool that I can use to run a 5-month sales forecast for any product. This uses the ai.forecast function and can help me stock products based on demand. Thank you.